Hi, good afternoon, everybody. We are going to begin in 2 minutes. So I'm just going to give other person some time to log on and we are going to jump straight into it. So get your books headed up with a date. We're moving forward into number theory with decimals. Just want to remind you guys that all of this information that we're actually covering between yesterday and today focuses a lot on questions that come on paper one. So we're going to try to wrap that up today so that by next week we could start focusing on topics that are focused on paper two. And we're going to practice some paper two questions moving forward. So 2 minutes and we'll begin. All right, good afternoon, everybody. Let us begin. So if you can hear me, just say good afternoon, just say hi in the chat so that I could, kick off our engagement as we usually do with our chat. Okay, awesome. So before we get started, I just want to show you guys something. So I'm just going to open up Google Classroom just to do a quick demonstration so you guys know that this would be your Google Classroom where you find everything. So yesterday, well, last class, I would have added a new tab, which would be class recordings, okay? So for persons who are absent or late, here is where you would find it. So I uploaded two versions, one version where you can download to your computer or one that you just have to open and it takes you straight to YouTube, okay? So our classes will be posted here for you to revise, for you to backtrack. If there's something that you missed and you want to see again, that's where you would go to find it. Let me just go back and also remind you that you have to always try to do your extra readings. And so here is where you would find our class presentation. You click on that and you would see what we will be doing next class. If you need notes that you did not get to write during the class, this is where you would go. And as you can see, all of it is right here for you to write your notes in your book. So there will be moments where I will let y'all know, okay, just make note. I need you to write these down in your book at another time. So here is where you would find that information, okay? Also with the textbooks, I have 2 more textbooks to upload. I would do so over the weekend because I'll also be posting your assignments. Now, this assignment is going to be multiple choice, so you don't have to worry about writing. You just submit your answer there directly. It would be posted on this week. So when you go and check this weekend, you would see assignment number 1, week 1, and everybody has to get that done before Monday because it's our first check-in to see if we would have understood everything we covered so far. So that sounds good? How does that sound? Everybody understand that? Everybody with me? All right, cool. So let's just keep it moving straight into decimals. Now, definition-wise, let me just move this up. All of this again should be revision. For most, there's specific details that you need to pay attention to because those are the little things that you're gonna need for the bigger things. So decimals are a convenient form of expression fractions without numerator or denominator. All right, they are also known as base 10 fractions since they have denominators that are multiples of 10, such as 10, 100, 1,000. So I'm gonna write, and we're gonna look at some specific examples. So everybody should have up your topic heading, which is decimals. And we're gonna kick it off using this. All right. So here we have something called a place value chart. So one thing I need you to make notice of, this is very important. So this is something I would recommend you guys try to copy in your book because this not only gonna help you with this topic, it's gonna help you with other topics. So let's take a look at what we have here. So I'm gonna use my pen and I'm going to draw a line. And this line is our midpoint when it comes to decimal numbers. Anything on the left-hand side of a decimal would be considered a whole number. Anything on the right-hand side of the decimal, so anyway, anything on this side, we have a whole number. Anything on this side is what we call a fraction number, a decimal number. So we're going to use some examples to highlight this. So for example, if I have 3.62, obviously, which section would be our whole number? What digit represents our whole number here? Remember, we use the chat to communicate, to talk to me in the chat, or you can put on your mic. It's up to you. The tree, somebody said the tree. Very good. And so the other portion, so this portion would be our whole number portion, which would be 1. And this section would be our decimal portion. And we usually call this number 3.62. A lot of persons just make a mistake and they call it 3.62. No, you call each individual decimal place by its number. All right, so this is what we need to take note of. So before the decimal point, we know we have 1, 10, 100, thousands. We know that. After the decimal point, our first decimal place is tenths, then hundreds, thousands, tens of thousands, hundreds of thousands. Now, this is the most important thing I need you to note. When moving from 1 to 10, what we usually do is multiply by 10. For each jump from each value, to move from here to here, you multiply by 10. So to move from hundreds to thousand, you multiply by 10. Now, so going to the left is increasing in value. So going to the right is decreasing in value. So obviously, if you're multiplying to the left, that means you're doing what to the right? You're dividing by 10. This information is going to come very important later on when we do the very difficult topics. So just remember that to move from tens to hundreds, you divide by 10, and that's why you would have divide by 100, divide by 1,000, etc. So let's move forward to some examples. So if I have 1/10, how is that represented as a decimal? Okay, you want me to repeat that?
Yeah, repeat that last part because you said either multiply by 100 or 10, so I'm with the confused there.
Okay, so let me erase it. Thank you very much for letting me know. We're talking about the place values, right? So if we have a number, for example, I gave you this example, 3.2. Let me give you another example. 26.4.42. Here, we identified the decimal place as our midpoint. It separates our whole number from our decimal number. To move from one decimal place or one place value, when you're going to the right, you're actually increasing by 10. So for example, look at here. 1 times 10 is 10. If you multiply by 10, that's how you move from 1 to 10. How do you move from 10 to 100? You multiply by 10. How do you move from 100 to 1,000? You multiply by 10. And for those who may not know, every time you multiply by 10, you add a 0. So for example, 2 times 10 is 20. It's just 2 with an added 0 to the back. If I had 20 times 10, what would be my answer? Simply adding 10 would give me 200. So all you need to keep in mind is to move from one place value to another, you are multiplying by 10 each time. But that's for the whole numbers. For the decimal section now, you're dividing. So the first place value is 1 over 10. And this is the same thing as saying divided by 10. So let me give you another example of that. When you get a fraction, if I tell you 1 over 2, this means 1 divided by 2. So let's take this value here, 1 over 10. 1 over 10 really means 1 divided by 10. So what would 1 over 100 mean? 1 over 100 would mean 1 divided by 100. 1 over 1,000 would mean 1 divided by 1,000. And you keep going on and on with the other place values. So the truth is, all you need to remember is that going to the right, you're multiplying by 10 each place value. But going to the left, you divide. No, I confused it there just now, apologies. Going to the left, you are multiplying by 10, and going to the right, you are dividing by 10. This is just general knowledge. I'm gonna give you more examples so that it makes more sense. So looking at this, if we have 1 over 10, it's the same thing as saying 1/10, which is 0.1, because this would be our first place value. Let's look at another example. 2 over 10 is the same thing as saying 2/10, which is 0.2. We're gonna move now onto the 1 over 100. 1 over 100 would give us 0.01. 7 over 100 would give us 0.07. Because let's look at the place values. The first decimal place is known as what? 10. The second decimal place is known as what? 100. So it would be this value over 100. Same thing with this one. 42 over 100 is the same thing as 0.42. This would be the same thing as 82 out of 100, 0.82. Now, we're going to do a quick activity, and I want everybody to tell me what they think. If I have 7 over 10, what would the decimal value for that be?
.7.
0.7. Everybody in the chat, thank you for those people who are using the mic. 0.7.
Mommy.
Let's go backwards. If I were to give you
Yes.
0.33,
Okay.
what would that be as a fraction? And for those who type
33
in,
over 100.
somebody said 33 over 100. For those who using the typing, you could use the slash as your fraction bar, like what Makita did. And that is correct. It would be 33 over 100. Why? Why over 100? Because that's the place value. So I'm going to go backwards just to make sure we understand. 10 is the first place value, decimal place value, and it is out of 10. 100 is the second place value, and it is out of 100. The third decimal place value is 1,000, so it's out of 1,000. And the fourth is 10,000, the fifth, 100,000, etc. Now, it is important to know this because when you're multiplying values, especially when it comes to money, when it comes to finding percentage, this is very important. All right, so let's move on. Let's do this quick activity. So everybody, you're gonna write down A, B, C, D, E, F. We're gonna do A, B, C, D, E, F, and the rest of it you guys will have to do individually on your own. So let's get the first one done. So I'm gonna give you guys 2 minutes just to copy this down, write your answer, and then we're gonna go through the answers together, just to make sure everybody understands this basic concept. So what we're doing is that we're converting fractions to decimals. A, B, let me just put a tick. I'll put a tick next to the questions that we're going to be doing now. So A, B, C, D, E, and F. And G. So just a quick reminder, tenth is the first decimal place value. Hundredths is the second place value. Thousandths is the third place value. Keeping in mind, don't ever get confused with tens and tenths. Okay, you guys have 1 more minute. All right. So anybody got an answer for A yet? I know you might be working on some of it still, but just for the interest of time, anybody got an answer for A yet? Okay, talk to me. Very good, 0.7. Keeping in mind that this is 7/10, so that's why it would be 0.7. Similarly, the same thing for B, pretty straightforward. What's the answer? Very good, 0.8. All right, let's go C, straightforward as well. Very good. And I want y'all to remember this, right? Because I'm going to explain to you guys why this is going to be important eventually. Especially with big questions, this information is going to be very, 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 very important. This skill actually is a skill. Okay, what about D? Anybody got an answer for D? Okay, I see 2 answers. Okay. Keeping in mind, right? This is 5 out of 100. So that means if I put my 0 point, I should not have anything in my 10th place, because there's nothing here that represents 10. And then we have 5. So your answer should be 0.05. Thank you very much. And it's very important to pick up on when you may have made a mistake. So good job. All right, next one, E. What would that be? 0.21. Excellent. And sometimes it is okay to back check it, just to make sure that if you go back to a fraction, it's the correct thing. So very good. Very good, guys. F. 0.42. Very good. Excellent. Let's look at G now. G is what I would consider our challenge. Let me see what we have. Excellent job, guys. Excellent job. So we have 0.005. Now I have a challenge for you that's not here. So again, your job is to use your extra time this weekend to complete the rest of it. But I'm going to give you a challenge. Suppose I gave you a number like this. Suppose I gave you 2 wholes and 3 over 10. Who could tell me what I would be as a decimal? This is where we now take it to another level. I didn't teach you this, but I want to see what you would do. You have 2, which is a whole number. Keep it in mind, a whole number. And we have 3 over 10. So I've seen some variations. I want you to pay attention to both rules. Do not let the whole number distract you from the basic rules. So everybody check back over your answer. I'm not going to say who's right or wrong, but check your answer before I move on. All right. So considering we know how to represent a whole number, we always know we put it where? On the left-hand side of your decimal. And we separated the whole number by putting a decimal point. So we put a decimal point right here. And then we represent our fraction portion by using our decimal rules that we just learned, and which means this would be 0.3. So the correct answer is 2.3. So very good to everybody. I'm going to give you one more. What about if I gave you 10 and 1 over 1,000? What would that be equal to as a decimal? So I see 2 persons so far. Very good, guys. Excellent. 10, which would be represented our whole number portion. And then because we have 1 over 1,000, it would be 0 for the 10th place, 0 for the 100th place, and 1 for the 1,000th place. Excellent. So everybody good with this? Everybody feeling okay? Now this is the easier part, because here, if you realize that we are dealing with fractions that have a denominator of 10, 100, 1,000. That's why we would call that a decimal fraction, but we're going to come up with that after. We're going to deal with that after. So let's look quickly here. These questions come in a multiple choice all the time. And because they're so easy, a lot of people just make mistakes with questions like this. So we just spoke about place value and value. I'm just going to give you a quick reminder. Place value is the position each digit holds, and the value is the quantity. So we have here a decimal number. So I'm just going to focus first on the whole number part. So I'm going to underline the 2. So we're going to do the first one together just to make sure everybody understands what we're doing and understands the meaning of place value and value, and then you guys are going to do the rest. So let's look at it. We call this number 25.36. So if I want to know the place value of the 2, I have to keep in mind, okay, what side is the 2 on? So because we know our decimal point separates our whole number and our decimal numbers, we know we're focusing on our whole number side. So that means the 5 would start off with 1, and that means that our 2 would be what? 10. So the position the 2 is in the 10th place value. But what would be the value of the 2, which would be the quantity of that 2? The quantity of that 2 would be 20. I've seen something in the chat. Let me see. I can hear, but no one can hear me. No. So I don't know if you were speaking, but if you were speaking, I didn't hear you. But you could always type your question. You can always type your concerns in the chat because I will see it. So the value of the 2 would therefore be 20. Okay. So let's go over this quickly again. Place value speaks about the position of the digits. Is it the ones, the tens, the hundreds, the thousands? Is it tens, hundreds, thousands? So that's what place values is speaking to. The value is talking about the quantity that the digit holds. So in this example, again, the value, we're speaking about the 2. What is the place value and the value of the 2? So the place value would be 10 because we realize that it's a part of the whole number side. So the 5 would be 1, the 2 would be 10. And the value of the 2 would be 20. Okay, so that's what we're looking at right now. The place value and value of the decimal numbers. For those people who just came in, no worries. Remember, we're gonna have the recording, so you would always be able to go back from the beginning and see what we did. So you just have to try to follow us where we are now, and you could always ask any questions if you need to. All right, so let's do the second one together. But guess what I am going to do now? I am going to underline a value, a digit in the decimal place. Anybody want to volunteer? What place value is the 5? What place value is the 5? So 2 persons gave the answer, 3, 4. Anybody, and you know what I love? Everybody giving us a different thing. So we could either agree or disagree with one of the following responses. Okay, so step 1, you have to identify what side of the number is that digit on. How do we know what side? We look for the decimal place. And I see some people making some changes, and that's perfectly fine. Self-correction is important. So the decimal place tells us that everything on the left is whole numbers. So that means that we not even know whole numbers. That means that we're dealing with the decimal place side. So what you should be thinking now is 10, hundreds, thousands. That's what should be coming to your mind. Because you do not start from the back. You always start from the decimal point. Okay, guys? You're dealing with a decimal number. So the 9 would be considered 10. So that means that the 5, it's going to be hundreds. And you have to write out the word because that's what place values are. Hundreds. THS. Just like how we have tens, you have to write hundreds. Everybody with me? And so what would our value be? Our value. So since we know it's hundreds, this is almost like a cue or a signal or a clue of our value. So it must be 5. It would be 5 out of 100. 5 out of 100. Because if you were to pretend like no other number was there and it was just 0.05, it would be 5 out of 100. Everybody see that? So we just did an example with the whole numbers, and now we did an example with the decimal place. So we're going to do another example now with the whole numbers. So let's look at 8. Let's take a try. What would be the place value of the 8? Let me see what everybody's thinking. Do not be afraid to make a mistake. That's what we learn. So let's go. Everybody talk to me. So some people saying ones. That's 3 people out of seeing 4 persons. How much people here right now? 11, 10. I'm to everybody else. Let's go. Participation is important. I need to know what you're thinking. If you don't know, don't be afraid to say you're not sure. All right. So excellent job. 1. Remembering we always write 1. So our place value, and keeping in mind, how do we know it's 1s and not 10s? Because when we look at our decimal point, we realize we're on the left-hand side, which means we're on our whole number side. So the first place value for whole numbers is 1. So that's how we know 1s. So 1s would be the place value. And what would be my value now? What would be the value of that digit? Okay, 1 person shared. Anybody else? And I'm telling y'all now, this is a very, very popular question. You must get a question like this in paper 1. Must. Every paper 1 I've ever seen always have a question about value and place value, and people always get stuck and they forget and they get confused. So it's very important for you guys to lock this in very tightly in your brains. All right, excellent work, guys. Very good. Last one, the tree. Let's go. Place value. Units and 1 is the same thing. And you know why it has both? Because sometimes they might ask you, in a question, they might say, what digit is in the unit place value? And you never hear about that. And you're like, I like to put all the different word in. So units, it means the same thing as 1. Very good, everyone. That's correct. The answer is 10 because it's right after the decimal point. So your answer is 10. And so what would be my value? What would be my value? Okay, 1 person share. Anybody else? Excellent work, guys. Excellent work. So far, we essentially are able to answer 1 question on the paper 1, multiple choice. Okay, so place value, value. So let's keep it moving. Now we're gonna look at adding decimals. Adding decimals. I want everybody to try this for me. Let me see. I don't want to just go into it. I always like to see what everybody knows. If you were to add this without your calculators, you use your calculators to back check, but you don't do it. How would I set this out? Because again, your first question on your paper 2, somebody laughing. Yeah, without your calculators. Because if this comes in a multiple choice, you better be able to do it without your calculators because you can't use your calculators for paper 1. That's why this section is very important. This is us developing skills that we're gonna need to answer questions in paper 1, which is without your calculators. Okay, I see 1 person with an answer. Everybody else, let's go. Decimal point must line up. Somebody asked an awesome question. So I've seen more than 1 different answers. Okay, very good question. Somebody want to answer her? Makita said yes, which is correct. That is the rules about adding and subtracting decimals. It must line up. So everybody take 2 minutes and you're gonna write this out in your books and you're gonna write the rule. You must align the points. That's the note. And that's what you're gonna put in red or in whatever bright color that you have. Because remember we spoke about that. So you're gonna write this sentence in your book in a bright color because that's a rule. This is a rule that you need to always have in the forefront of your mind. So copy this down. in a bright color, because this is a rule. When adding decimals, you must align the place values. And another way to say that is you must align the points. So you could put below, must align points. Let me see if my pen can give me a break. Must align points. So while I do it on the board, essentially, I need everybody to try it in your books, because this is notes. This is what you would use for revision. So I'm going to set this out. So I have my 0.17. So I align my point. So I know 0 goes here, 7 goes here. And what most people do to keep them from getting confused is by adding an additional 0. That is something that you can do to help. So when you add 7 and 0 is 7, 7 and 1 is 8, put back the point, you put back the 0. So that's what your answer should be. Let's go. Next one, you do the same thing. You align, you set it down, 6.24. The 0 aligns with your decimal place, 4, 1. And then you add a 0 here to take up that space. So what would be our answer for this one, guys? Anybody got the answer yet? Let me see. Let me set out this next one. 0.12, 0.742. And so I have to put my 0 here to take up this space. So let's look at B. Let me see what answers anybody got. Somebody has 10.034. Somebody has 1.034. Okay, and remember, just to be certain, you could always back check on your calculator to see if you made a mistake. So we add in, and you see, we add the zeros to eliminate the possibility of getting confused. And I'm going to tell you the truth, as simple as this sounds, when you're in an exam and you're stressed out, you want to eliminate any possibility of making a mistake. So all these little trivial things, you do. So you should have 4, 3. Because 6 and 4 is 10, how do we work this out? We put our 0 and we carry over our 1. So that's how we end up with point, and you put your 1. 1.04. 1.034. And the last one, anybody got an answer for that one? 0.862. So let's see, we're going through. 2, 6, 8 point, okay. So that's what we should have had. So the key thing to take away here, and the key thing here to remember is simply aligning the decimal point or aligning the place values. So 1s on the 1s, 10s on the 10s, 10s on the 10s, 100s on the 100s, etc. All right, let's keep it moving. So I'm not going to do up here, but I want us to do 2 questions from here. I want y'all to try this one for me, G. Everybody try G. Let me see what you get without your calculators. So we trying G. So 0.86 minus 0.002. So I'm going to start to set it out. I'm going to set it out. So we have 0.86 minus 0.002. And I'm gonna tell you, a lot of people that struggle with this. If you struggle with it, that's perfectly fine. So I see one answer. Anybody else? How would you go about doing a question like this? First of all, you realize even though nothing is here, all we need to do is put a 0 here to take up this space. And then we subtract as usual. So I'm going to use a different color. Because we cannot subtract from 0, we're going to borrow 1. We're going to left back with 5, and we put our 1 here. So 2 into 10, 8. 0 from 5, 5. 0 from 8, 8. 0. All right. I'm doing all of this for a specific reason, guys. This is your foundation, because when it comes to us doing the more challenging questions, I need to make sure I definitely cover it with you guys, so we shouldn't have a problem when we have difficult or challenging questions. So excellent job for those who got that, who tried. Now let's look at the bottom section. That's where I want us to focus on. In each of the numbers below, does the 5 represent 5/10, 500, or 5,000? So let's do this quickly. A, what is it? 5/10, 100, or 1,000?
Hundreds.
Thank you. Next, B, we're moving along quickly. We're just doing a quick revision. B,
Tens.
tens, excellent. I'm gonna move on to E. E, what does it represent?
Thousands.
Thousands, excellent. All right, so that means we should have an understanding of 1, the place value of decimal places, the value of decimal places. We should be able to take a fraction that has a denominator of 10, 100, or 1,000 and directly change it into a decimal place. We should be able to add and subtract decimals, because we know the rule is you must align the decimal points, you must align the decimal places. Straightforward. Multiplying. But before we go to regular multiplying, we're going to look at this topic. So what you're going to write for me is multiplying and dividing with decimals by 100, 10, and 1,000. So you're going to write the topic, multiplying and dividing with decimals, and then in brackets, you're going to write by 10, 100, and 1,000. Keep it in mind, every time we do a new topic, you write the new topic with a bright color. So if you've been using purple, red, because what you need to be able to see is the difference between your examples and your notes and your new topics. All right, so I'm going to tell you what you're going to write now. You're going to write down this. Multiplication moves the point to the right, and you're going to write division moves the point to the left. That's the first thing you're going to write for me. And this is also in a bright color. And when you finish writing that in a bright color, you're going to put this in a box. This is a rule. This is a rule. This is a rule that's going to save you so much time and energy in the multiple choice. You're going to be able to find answers for certain questions way faster if you know this skill. So let me know when you guys done, please. Let me know in the chat that you're finished writing down what I asked you to, which would be the topic, multiplying and dividing with decimals by 10, 100, 1,000. And then you're writing on the first rule in a bright color. Multiplication moves the point to the right. Division moves the point to the left. And we're going to talk about what does that mean? What are they talking about moving the point? So just one person is finished, so just waiting for everybody else before we move forward. All right. Now, for now, because this is a lot to write, we're just going to look at this, but you're going to need to leave some spaces to write this after. So you're going to count out your lines, because these are the rules. Well, these are the specific rules. to multiply by 10 and 100 and 1,000. And I'm going to read them out for now. So don't try to kill up yourself and write out all of this now, guys. You do that when you have time. We're just going to be learning and practicing for now. So let's go through it. 1, it says, whenever you're multiplying a decimal by 10, you move the decimal place, move the decimal point once to the right. I think I want to do a short version of this, so I think I'm going to do that. Or I could leave it because it's pretty straightforward. So when you multiply by 10, you move the decimal point once to the right. When you multiply by 100, you move it twice to the right. When you multiply by 1,000, you move 3 times to the right. When you're dividing now, where the point moving? To the left. So when you divide by 10 is 1 jump. When you divide by 100 is 2 jumps to the left. And when you divide by 1,000 is 3 jumps to the left. So let's look at an example. But what do you realize here about this first example? Is this a decimal? Talk to me. Do we apply the rule here? Does the rule apply here? For the first one?
No.
It does not apply to this first one. And this was intentionally put here to see if you are observing. You could only jump if there's something there to jump. And I'm going to show y'all 2 rules. I'm going to show y'all 2 things here now. First thing first, there's a rule. What happens when you multiply a whole number by 10, 100, and 1,000? So everybody, you're going to write this down for me now. After you skip the space for the notes from before. So you have whole numbers. What happens to whole numbers when you multiply them by 10? So when you multiply by 10, what happens? You add 1 0 to the number. So for example, I'm going to use an example of 3. So 3 times 10 would be 30, because all we did was what? Add a 0. What do you think gonna happen when you're multiplying by 100? What happening when you let me hear?
You're gonna add 2 zeros.
Very good. Very good. You add 2 zeros. So we're writing this down now. So example, I'm gonna use 3 again. So I'm gonna say 3 times 100. So all we simply do, we add 2 zeros. All right, next one. You're multiplying by 1,000.
Well, that certainly injects a little bit of text, doesn't it? Because then all of a sudden you realize I'm going to give a point away. The point's going to go up there. And it's given the point away because it wasn't proactive. And there's a difference between being proactive and reactive.
Now, some of you would have known this from before. Some of you may be learning this for the first time, but it is very important for you to remember always. Because when you have consumer, when you have a lot of questions and you have multiplied by 100, nobody expects you to go multiply out all of this or put it in your calculator. You should just know you simply add 3 zeros. Now, one of the things I want you to know too, when you're dividing by 10 and 100 and 1,000, if there are zeros, you do the opposite. So if you're adding zeros when you multiply by 10, what would happen when you are dividing by 10 and there's a 0? You remove it, okay? So I'm gonna give you one quick example about that as well, because I just wanna make sure that we all know these basic rules. So, for example, 120 divided by 10, it simply means canceling off the 0. This is for when there's a 0, okay, guys? If there's no 0, you can't cancel nothing. If you have 300 and you divide by 100, you know how much you're going to be canceling in this example. You're going to be canceling 2. Zeros, so you end up with 3. And the same thing happens when you are dividing by 1,000. Okay? General knowledge. All right, so let's look at the first example. 362 times 100. We don't have any decimal place right now at this point. So what would our answer be? We don't need a calculator, so we don't need to do long multiplication. All we need to do is add what? 2 zeros, right? So what would our answer be? Excellent. Now, one of the things I want y'all to always practice as well is putting your commas in your number. And you usually put your commas 3 digits from the back. So for example, your answer would be 3, 6, 2, 0, 0. And then you count from the back 1, 2, 3, and you put your comma. All right, so let's look at B. In this case, we have a decimal and it asks us to multiply by 10. So what's the answer? We were told when you're multiplying, you move the decimal place 1 place to the right. So I'm just gonna zoom in a little bit. So I'm gonna take my decimal point and I'm gonna jump it 1. So now it moved from being between the 4 and the 7 to be between the 7 and the 3. So your answer is 47.3. Excellent. Next one. Now this is a tricky one. This is another trick I want to show you guys. What type of number is this? This is a whole number, which means that there are no decimal places there. But do you know that we could put a decimal place to make it a decimal? Where would we put it though, without changing the number? So I'm gonna rewrite this so we could see better. 576 is the same thing as 576.0. So if you put a decimal place to the back, it doesn't change the number, and that's where you would need to put it. And so, following the rules, if I want to divide by 10, I move to the left 1. So my answer will be 57.6. Everybody see that? I want you to try D now. These are more challenging questions. I want to see what y'all would get when you try that one. It's meant to challenge you, but I want you to try still. I want to see what you get when you try it. So we know 1,000 means 10, 1,000 means 3 jumps. So what would happen if we do 3 jumps? Try it and see. So I'm gonna write the number 4.2. Anybody have an idea? If no, that's okay, we do it together. So let's go. So we know we need to go to the left, but you realize that you're close, T, but you went to the wrong direction. Because remember, we're going to the left. Remember division. So let's go. We jump in 3 times, right? So we go in 1, 2, 3. So this is where the point's gonna end up. So what do you think has to happen in these spaces? We have to put 0. So it's going to be, we're gonna add a 0 here, a 0 here. And do we ever have a decimal with just 0.0042? No, so we need to have a 0 in front as well. 0. So learning opportunity. So for those who don't know, who was not sure, that's what we would get. Everybody see that? So we can do a few more examples of this nature because I really want y'all to get familiar with this specific topic. Make sure you have these examples in your books because again, this is what you will be looking at for the basic revision in your notes. So let's go. Do these questions for me now. So everybody try A for me, please. Keeping in mind what happens whenever you have a blank space when you're jumping. So try this one for me. All right, so I'm gonna give you guys a couple of seconds to write this down and get it in your books. Anybody have an idea of what the answer is for A yet? So one person said 450. Okay. Okay. Anybody else want to share? Excellent work, guys. Excellent work. Keeping in mind. Bakini, you jump too much. If you jump too much, that's okay, you know. Remember, we multiply. The truth is, how do you remember how much times to jump? Look at how much zeros they give you. So 1 0 for 10 is 1, 2 zeros is twice, 3 zeros is 3 times, okay? So in this example, we only jump in twice. So there we go. When we jump 1, we end up in the back here. When we jump again, so we know we have to put a 0 in this space. So that's how we would end up with 450. 450, 450.0, same thing, guys. So excellent work. Let's go next one. Excellent. You see, that's important, being able to identify where you went wrong. So let's go. Everybody, try the next one for me now. Okay, I've seen something. So 0.03. All right. I totally skipped the 5 and gone past. Okay, guys. So we multiply by 1,000 means we jump in 3 times. Let's see what we get. 1, 2, 3. So our point would end up here. We put a 0. Now this is what I want y'all to realize. In general, should I write 0, 0, 3, 0? Now, technically you are correct, but do we write whole numbers like that? Do the numbers in front hold any value? They do not. The value of zeros only are important if a decimal point is there. And because there's no decimal point there, this is a whole number, and this whole number is just 30. So you would just put 30. Okay, guys, this is where we go advanced. So writing this version is not incorrect, but if we're looking at what CXC would need or what CXC would expect from you, it would just be 30. All right, everybody got that? So we're gonna do 2 more and then we're moving on. So C. Let's go. Get C done for me, please. Get C done for me, please. And I want y'all to know this is what my math class is about, putting you to challenges, for you to think, for you to learn, for you to practice, okay? So I'm waiting to see the responses for C and then D. I've seen some emojis. Okay, I get some responses. I'm waiting for everybody else. No, I've been seeing consistently some responses from some people. I don't want to have to call persons, but try to, as much as you can, try to contribute to the discussion, okay? Share your answer, don't be afraid, because it's gonna show me if I need to go over something or explain something over. So make sure you share with me, okay? All right, so let's see if you guys are correct. I'm gonna rewrite my decimal here so I could give myself some space to jump around. All right, so that's my starting decimal. So I'm dividing by 100, so that means I'm jumping twice. So we're going 1, 2. So this is where my point is going to end up. And so I have to fill up these spaces with zeros. So my answer is actually 0.0064. Let me see. That's what everybody get. Excellent. And now I'm seeing the answer for 1,346 divided by 1,000. Excellent work, guys. Good job. So we can move on. We should have this unlocked. We started off with our decimal place to the back because we know if we have a whole number, that's where we put it. And we jump 3 times. 1, 2, 3. And so we drop our 0 in the front there. So we get 0.346. Excellent work, guys. So let's keep it moving. We got some work to do. This activity, again, is for you to do in your own time. So for persons who want to practice, I recommend everybody to do this. I'm going to check in with you guys to see if y'all getting some practice with this, because the faster you could do this, the better it is. All right, multiplying decimals. Multiplying decimals. I need everybody to copy this down because this is another rule. It says to multiply decimals. First, you multiply as if there's no decimal. So you do your regular multiplication the long way. This is where the most important step is. Next, you count the number of digits after the decimal point in each factor or each number. Finally, you put the same number of digits behind the decimal point. I'm going to give you a shorter version of notes of this. So don't worry about it. So we're going to look at some examples now. Oh, you can't see? Okay. I'm going to write it over in a shortened form using an example. So step 1. So let me write this, copy down this version instead. So step 1. Multiply regularly. So that means you would set it out just like how you would set it out. Step 2. Find the total decimal places. But not. And another way of saying decimal places is DP. So anytime you hear somebody or me or a textbook or a question ask you to find something to DP, it means decimal place. And step 3, so these are the 3 steps we're going to be looking at. So let's look at an example. So let's look at this example. 3.12 times 1.1. Here, I intentionally did not set out the decimal place under the decimal place. Why is that? Because it's not important. The only time it is important to make sure your numbers are aligned is when you're adding and subtracting. So step 1 says to multiply regularly. So if we were multiplying regularly, we're gonna first multiply by 1, right? So let's do that. 1 times 2 is 2. 1 times 1 is 1. 1 times 3 is 3. You do not pay attention to the decimal point until the last step. So we keep going again. So now we're gonna multiply by the second digit, which would be this one. So we know that when we multiply by this digit, it's 10. That's why we have to put a 0 here. So then we have 1 times 2 is 2. 1 times 1 is 1. 1 times 3 is 3. Here, we have to make sure we align our numbers because of our addition step. So 2 plus 0 is 2. 2 plus 1 is 3. 3 and 1 is 4. And 3, and obviously a 0 would be here, so we just bring down the 3. Now, let's do step 2. Find the total decimal place. So for the first number, how many decimal places we have here? Talk to me. 2. Very good. So you have 2 DP. For the second number, how much decimal places do we have here? 1. When they ask you to find the total, what does that mean? How do you find the total of anything? You add, right? So it means then that our answer should have 3 DPs, which means 3 decimal places. So how do we find 3 decimal places? We start counting from the back. So the 2 would give me 1 decimal place. So we count in 1, we starting from the back. So we count in 1, 2, 3. So here is where my point would be. And so my answer would be 3 0.432. You know why this is important? I'm going to tell you a trick that CXC does. CXC does give you 2 decimals to multiply, and they can give you the answers, 4 answers with all the same digits. And if you look at it, you know what is the difference between the digits, the number of decimal places. And just by that, you should be able to pick your answer. They don't expect you to go and calculate the whole question because it's going to take too long. You should not spend more than 1 minute and 30 seconds on one question. And if you work out that big multiplication, 2 minutes done gone, 3 minutes done gone. So these are the things you have to pay attention to. I just multiplied 2 decimals. The first decimal had 2 decimal places. The second decimal places, the second number had 1. So that means my answer must have 3 decimal places based on the rule. Everybody have that? So please copy down this example. Please make sure you copy down this example, especially where they are talking about the DPs, finding the DPs, and you see how I use the different colors here when it came to the decimal places. That's very important because you need to be able to see how did you get your decimal place point to this point. So copy that down. And I reference the exam a lot so that when you learn these things, you understand how you're going to use it. So every time I teach you something, I'm going to let you know, okay, remember this, because when you go to the exam, this is where you would see it. This is when you need to use it. All right, so let me know when you guys are finished so we could move along. So that's 2 persons finished. All right, awesome. So let's keep it moving, guys. So I just want to recap quickly. When you're adding decimal places, it's very important to align your decimal points because you have to make sure 1s on the 1s, 10s on the 10s, etc. When it comes to multiplying, it's a whole different ball game. You follow these 3 major steps. You multiply like normal, but then you count your decimal places that you have in total, and that is going to tell you where you need to put your decimal point in your answer. All right, so we're gonna keep moving. Let's see how much for time it is. Let's see if we're on target. 27. Okay. Okay, so let's use this as a checkpoint. How everybody feeling? Everybody good so far? Y'all with me? Y'all understand? Y'all good to go? Talk to me. So I just see 2 persons responding, 3. All right. Now this is a little quick activity here for you guys to do again, not 100%. If you know you're struggling, you could practice. If you feel confident, you could do a few of them. This is just to keep you guys engaged on days that we don't have class. So this is for you to do in your own time. So we're moving right along to division. All right, so let me just break down this here because this is very important. How to do long division with decimals. Now, dividing decimals is very important. You cannot divide by a decimal. So here it gives us some steps. So let me read. When we try these, do we put them in Google Classroom for feedback? Yes, you can. Actually, 2 things I want you guys to know, that when it comes to you doing any extra work and you want me to check it, you WhatsApp me. WhatsApp me directly. Take a picture of it, and then you're going to WhatsApp me. Okay? And I'm glad that you mentioned that because tonight, after this class, since we're going to be done with week 1, I'm going to be posting some assignments. Easy. It's going to be multiple choice, and it's going to be similar to how your registration form was. You just click on the answer and you submit. So I need everybody to work on that before Monday. I'm actually going to be messaging you guys to make sure that you did it. So those persons who did not do it, I will be reaching out to you because it's going to be like a little quiz just to make sure that you understand, that you see for yourself if you could answer questions on your own, etc. Okay? So just a heads up about that. All right, so let's look at, we're moving straight along, decimals, division, right? So you're gonna head up this part, division, and I'm going to write again a short note for you to write down. You cannot, this is the number one rule, you cannot divide by a decimal. You cannot, it's a bit, you could use a calculator too, but when it comes to long division, you cannot divide by a decimal. So you're gonna put to the top NB, which means note. For those who don't know, NB is something that you have to pay attention to. And you're gonna write, you cannot divide. You cannot, guys, I just write better than this in real life. And it's just like this thing, this is annoying me. You cannot divide by a decimal. This is very important. And actually, out of everything we do today, this might be the most important because this is, for some strange reason, questions that come on dividing decimals, people forget. And so they always end up with the wrong answer because they forget this very basic rule. So after you write this down, then you're gonna write 1. If the number you're dividing by has a decimal, move the decimal point all the way to the right, and then you count the number of times you move. This is very important. So whether you do to one number, essentially you have to do to the other number. So it says here, then move the decimal point in the other number you're dividing the same number of places to the right. And so we're gonna look at our first example. Welcome back. So you're gonna take note of these 3 points, and I'm gonna do a demonstration of what it's talking about. So let's look at it, let's look at it, let's look at it. As easy as this. So I remember, guys, don't stress out yourself to write this down now. Remember, you have access to this 24/7. You can write this down in your own time. So we're moving along with the actual activity. Again, the only thing I want you to write right now is this part. Note, you cannot divide by a decimal. And then everything else you could write after. So we're going straight into the examples. 1. This is one way of saying division. You see this bar? I need you all to know this. So I'm going to write it in 3 ways it could come. So the first way the way that we're used to is seeing 64 divided by 0.02. But another way of writing the same thing is by writing it like this, what they have here, with a slash, 64 divided by 0.02. And the next way this could come is in fraction form. So if you were to see this, 64 over 0.02, this literally just means 64, and the bar means to divide by 0.02. All right, so let's get to it. Since we know we cannot divide by a decimal, what they're essentially saying is change this from being a decimal to a whole number. If I want to change this to a decimal place, from a decimal place to a whole number, it means I need to move this point from here and put it where? To the back of 2, right or wrong? Because if I move it 1, 2, what does it now become? It now becomes 2. But what they're saying is that if you're going to do it for this number, you have to do to the other number too. Because remember, it's all about maintaining balance. So here does not have a decimal point, but we learned that we could put the decimal point to the back and we could move it twice this. So what's going to happen here? 1, 2. So instead, this is going to become what? 6, 4, 0, 0 divided by 2. Now, doesn't this look more manageable? So now we're going to do this using the long division because that's what CXC expects of you. So you have your division. Which number goes where? The number that you are dividing, you put in here. And the number that you're using to divide goes out here. And you divide accordingly. 2 into 6, 3. 3 times 2, 6. You subtract 0. You bring down the 4. Bring down the 4. 2 into 4 goes twice. 2 into 2, 4 times. Minus 0, you bring down 0. But 2 into 0 goes 0 times. So you put the 0 here, boom. Same thing here, bring down the 0. 2 into 0 goes 0. So our answer is 3,200. Boom. All right. Keep it in mind. What is the most important part? This part here. This whole moving the decimal part here is the most important. Why are we moving the decimal point? Because we cannot divide by a decimal, so we're going to change it to a whole number. So essentially, what rule are we using here? It's like we're saying, let's multiply by 100 to both numbers to make it into a whole number so that we could use it to divide. So let's look at another example. The other one was, I love this example actually. So let's look at that. I'm going to come down. So the next example is 12.33 divided by, and I have here 0.4, but I'm going to put 0.3. That's supposed to be 0.3, to be honest. And I know why. Because if we don't use 0.3, we're going to have a hot mess when we start to divide. All right, so talk to me now. Let's zoom in. Can I divide here? Can I just go into dividing? Somebody, anybody want to volunteer to help guide us through this one? What do we do? Where do we go? What's the first thing we must acknowledge? Can we divide or can we not divide? We can't. So what do we do?
So we're gonna move the decimal point from the 0.3, and we're going to
Go ahead.
and we're gonna move it 1. So
Very
it'll
good.
become 3.
Excellent. So we move it once and we're gonna become
3.
3. Excellent. But what happened is, are we done?
No.
What we need to do to make sure it's balanced?
Well, the other one, we'll have to move it 2 places because we need to move the points all together. That's my view on that one.
Okay, I appreciate your contribution. No, I love what you say because you know why? That would allow me to make a clarification. Remember, balance is whatever you do to one, you do to the other one. So guess what? In the example before, we did the same number of jumps for both, isn't it? But here, how much times did we jump to make this a whole number? Just once. So you only need to jump once here. Okay? You have to only jump the same number of times for both sides. Makita, don't stress. We got this. Remember, we're staying positive, we're staying focused. So let's go. What would this number become then? So we have two new. Oh my God, hold on. My word's not coming out. We have 2 new numbers. So the first new number that we have is 3. And what would be the second new number? So we're gonna put our division sign. So instead of 12.33, what will we have now? Cricket. Nobody typing. Nobody, anybody? That's okay. If nobody want to share, that's perfectly fine. Okay, I see 2 people sharing. Thank you very much, girls, ladies. 123.3. You see the thing is, right? All you have to do is stay focused on the why and the what and the when. So we know what is the purpose of all of this. 1, we know we cannot divide by a decimal. So we need to change 0.3 to a whole number. What do we do to change this to a whole number? We move the point once because we only need to move it once to make it a whole number. So we got our 3, but we have to remember, if I change one number, I have to change the next number too. I have to do the same thing. Math is about balance. Whatever you do to one thing, you have to do to the other thing to maintain the balance. So if I jump once here for this number, I have to jump over here as well, 1. So now we have two new numbers, and now we could divide. So let me show you how we divide. So you put your division sign. So you're gonna put 123.0, and you don't even need to put those 0.0 because we already know that. Why do I have 123.0 when it's supposed to be 123.3? And I'm telling y'all, this is mistakes that we just make all the time. Like you're so focused that you ain't even realize you write down the wrong thing. So don't be afraid to ever tell me, Miss V, you wrote down the wrong thing, because that happens a lot. And this is all about back checking as well. Because in the exam, when you're under a million stress, this is always something that you should look out for. All right, so there we go. We divide them by 3. So everybody paying attention as to how we divide by 3. And you know why this is important, people? Our next section is consumer. It has a lot to do with money. What do you think money is? $12.45. This money and this money and this money. You have to be strong in this. If you're not strong in this, consumer is going to rip you apart. So if you're not feeling strong now, that's perfectly fine. Just focus. So there we go. 3, you can't go into 1. So we're going to say 3 into 12. 3 into 12 goes 4 times. 4 times 3, 12, we subtract. How much we end up with? 0. Everybody following me? All right, what we do next? We bring down the 3. And then we say 3 into 3 goes 1. 1 times 3 is 3 minus, you get 0. Who we bringing down next? We're bringing down this 3. This is the part you need to realize. You see this point here? Wherever it is, you got to put it back up here. So that's the part that's different from the example before. So you have to always remember, if there's a point here, you put a point right above it on your answer line. So we keep going. You bring down your 3. 3 into itself goes 1. 1 times 3 is 3. And so we are done, 0. So our answer is actually 41.1. And somebody check in the calculator, make sure it's right, please. I don't need people to do that often. So back checking your calculators, everybody, make sure you get the answer. Let me know if that's the answer you got. Anybody back check it? Correct answer? Excellent. Now we have another one. I want y'all to try this one for me. Even if you don't make it to the end, that's okay. I just want to see how far you could get. So we have 15.05 divided by 0.005. So the first thing you're going to do is you're going to try it on your own, and then you're going to back check it on the calculator. So I'm going to give you all a time challenge here. Time challenge. I'm giving you 2 minutes. So once the 2 minutes is up, let me see how much persons could get this here correct. Let's go. Once you finish, just hit done if you finished before. Okay, one person is done. You guys have 1 more minute left. That's 2 persons. Three. You have 20 seconds to go, guys. Let's see if you could get there. Let's go, let's go. All right, time is up. So if you didn't make it for the time challenge, that's okay. Remember, it's all about increasing your ability each time. You should be getting a little better each time. So let's do this together. But anybody want to share what they got? Let's see what y'all got to see if we would get the same thing. Anybody want to share the answer? Okay. So those three persons, those three ladies got 3010. Somebody got 3.01. Okay, we got a different answer. Anybody else? All right, so let's take a look at it. Let's see if we are on the right track. All right, so let's go. We are dividing by a decimal, and we know we can't do that. So step one, change the number into a whole number. So we're gonna move our point. So we go in 1, 2, 3. So that means we need to move our other point 3 times as well. So we go in 1, 2, 3. So what I'm gonna do now is write down our two new numbers. So our new number is 15050, right? Divided by 5. So before we move on, everybody get this? Even the persons who didn't get to share the answer. Did you get this part right? Because that's the most important part, actually. Talk to me. Everybody get this part? Because out of a class of 9, 10 persons, only 3, 4 people are talking. So what's up with everybody else? Y'all okay? Y'all getting through? Y'all got this? Okay, good, 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 good. All right, so this is what you should have. And if you have this, you're on the right track. So now we're gonna do our long division. So long division, 1, 5, 0, 5, 0. So we go in, we divide it by 5. So we can't say 5 into 1, so we're gonna say 5 into 15, which is 3. 3 times 5 is 15. Subtract, we're gonna get 0. So we bring down this 0. Can we divide by this? No, so we put 0. That's very important. You must follow, if you realize that the answer to the top is going to correspond with the number below. So you see 5 can go into 15 3 times, you put 3 right above. 5 cannot go into 0, so you put the 0 right above. So we're gonna bring down the 5 next. So we're gonna say, we bring down the 5. So 5 into 5 goes 1. So 1 times 5 is 5. Subtract, you get 0. You bring down this 0. 5 into 0 goes 0. So our answer is 3010. Everybody see that? Okay, so now this is our time to decide if we understand this part or not, because I'm gonna be honest, this is probably the hardest part of adding, multiplying, subtracting decimals. So I need everybody to talk to me. How you feeling about the dividing of decimals? Keeping in mind the step. Step 1, you have to change the decimal to a whole number. Step 2, whatever you do to the first, to the number you're dividing, you do to the other number, and then you divide as normal. So that's 3 people. I need to hear from everybody else before we move on. If you don't understand, you could even send me a message directly. Like, you could choose who you could send a message to. So you could always send me a message like directly instead of to everyone. I would be the only person to see it, so that person could let me know how they feel about it. So since people saying kind of, let's just do one more for the road. Let's see if we can get everybody. Okay, excellent, awesome. So let's do one more for the road. So those people who got it, good. Those people who don't got it, that's perfectly fine. You know, some things you're gonna get fast, some things you will not. So let's do one more before we move forward. And I'm really happy that we will have this video for you guys to look and rewatch and practice. But let's try this one together. So let's look at, where is my pen? Okay, let's get it up here. Let's look at 6, 8, 2, 4 divided by, and I'll put my point right here, divided by 0.2. So let's go through this one together. Step 1, you ask yourself, can I divide this just like that? Everybody answer me, yes or no. Can I divide these two numbers just like that? Don't mind the ice cream truck in the background, guys. Okay, so we all agreeing no, good. So since we cannot, what do we have to change? Which number are we changing? The first one or the second one? Which number we need to change to a whole number? Both? Okay, very good. So which one can tell us how much times we need to jump? The second number, very good. So how many times y'all think we need to jump to make this a whole number? 1 jump, 2 jumps, 3 jumps. Everybody talk to me. We're going step by step. Okay, very good. So we only need 1 jump. Because when we make our 1 jump, when we make our 1 jump, what would that number become? So this number gonna change. What does it become now? What is our new number? So instead of 0.2, what is it now? Very good, 2. All right, 2. Good. Now, what do we do next? Whatever we do to this number, we must do to this number. So we're gonna end up with how much jumps now? 1 jump as well, right? And when we have 1 jump, what does this become? What is the new number for the first number? Okay, I see 68.0. So my question to you is, what happened to the 2 and the 4? Remember, you just can't throw away numbers like that. So your jumping is correct, but you have to keep those 2 other numbers. Okay, so we're gonna end up with 68.24 divided by that. All right, so check-in point. So everybody understand this part? At least this part? I just want to make sure y'all understand this part. So let me know. So everybody else who not feeling as confident, do you understand this part? And this is where the memorization comes in, okay? Remember I was telling you guys memorization is an important part. This is the part you gotta memorize, the steps. Okay, so now we're gonna just divide as normal. So we're gonna set up ourselves now. We're gonna set up ourselves 68.24. And we divide it by 2. So I'm just gonna move up a little bit to give us some space. So let's go now. 2 into 6. Now the thing is, you have to ask yourself, is it division is my problem? Because some people struggle with division, long division. So you need to decide, is long division the issue? Is the numbers the issue? All of these things you have to look at, okay? So 6, 2 can go into 6 3 times. 3 times 2 is 6. Subtract, you get 0. You bring down the 8. You ask yourself, 2 into 8 goes 4 times. 4 times 2 is 8. Subtract, you get 0. Before I move on, what must I put after the 4? Before I continue, what must I put after the 4? Thank you very much, the decimal point. Okay, remember it doesn't move in this case. So you put back the decimal point and then you continue. Excellent job, guys. So now we bring down the 2. Bring down the 2. 2 into itself goes 1. 1 times 2 is 2. Subtract, you get 0. And last but not least, you bring down the 4. 2 into, you bring down the 4. 2 into 4 goes, I don't even know why I write this 4 there. Apologies. Let me try that again. Give myself some more space. So we bring down the 4. So 2 into 4 goes 2 times. 2 times 2 is 4. So we have our answer. You get 0, we have our answer. So our answer is 34.12. Okay, so I really hope that this helped a little bit, provided a little bit more clarity. Again, you have access to the video to watch it as much as you need to, and there will be some questions for practicing, okay? All right, so we're just gonna touch on this. We got 20 more minutes. I understand better now, thank you, awesome. What about everybody else? It helped a little bit? It was a little better? Okay, good, excellent. Thank you very much for letting me know so I could have gone over it for you to understand. Awesome. So we're gonna move on to fractions quickly. Now, I'm gonna tell you the truth, this is where we're looking at paper 2 now, because the first question on the exam paper for paper 2 is going to be a add, multiply, subtract, divide fraction question. Usually part B is a decimal question where you have to multiply a decimal or divide a decimal. And then the other part of question 1 is consumer. So when we're finished with this section, we should be able to answer any paper 2 question 1 part A. All right, so head up, fractions. Head up fractions. And guys, please take some time to do some practice. I'm going to send some questions for practice, especially since I know that dividing decimals was a bit challenging. I'm gonna add some dividing decimal practice questions, and I'm gonna give you the answer so you can check it on your own. So let's go ahead of fractions, and we're going through. So I'm just gonna read this quickly. Remember, we're not gonna write none of this down. All of this would be online. And also there's textbooks with all this information and even more examples. So don't be afraid to go open the textbooks, practice on your own. You have notes that are in different words that might make it even more clearer to you. Use the resources that I provide to you guys, okay? So yeah, a fraction is a part of a whole. So it's a piece, it's a portion, it's a percentage. And so the whole we use to represent 100%. A whole is considered as a quantity when the numerator and denominator is the same. So for example, if I have 4 pieces out of 4 pieces, that is equal to 1 whole. If I have 100 out of 100, that means it is equal to what? A whole. Okay, so if I have something and I cut it up into 8 and I have all 8 pieces, that means I have the whole cake. If I have a pizza with 12 slices and all 12 slices is there, that means I have 12 out of 12, which is the whole pizza. So that's all this really is saying to you when it comes to how do you represent a whole and understanding fractions. No, a fraction is part of a whole, or it's the same thing repeated, sorry. So this is how we know fractions to look. We have the numerator, we have the fraction bar, and we have the denominator. This is a perfect image of a fraction. What is very important about fractions? The sizes must be equal. So for example, if we're going to divide a circle into 7 parts, all 7 parts must be equal. And so we have here 3 out of 7 in diagram form. This is just a quick demonstration to kind of just bring back your memory. All right, so this is the first part we're gonna do. Equivalent fractions. And this part is very important because this is what we're gonna use to do a lot of things. So here we have a fraction. Tree is a fraction. The fraction above represents 3 equal parts out of a total of 7 equal parts. So that's why you get 3 out of 7. The whole would be 7 equal parts out of the total of 7 equal parts, which is what we were saying, 7 out of 7. Now, what we have here is called a proper fraction. So all I need you to do is write this here, a proper fraction, and write these examples. So a proper fraction is where the numerator is less than the denominator. So once the top number is smaller than the bottom number, that's what we call a proper fraction. So all I need you to do is write a proper fraction, and you could write out this definition quickly because it's pretty simple. Is where the numerator is less than its denominator, and you're gonna write these examples: 2/9, -3/4, 7/10, because that's where you're gonna need to know these terminologies. Finish? So all we're gonna be doing is just writing some of the major points. We're not gonna be writing every single thing because again, all of this would be online already. Okay, so we have a proper fraction. So anytime you hear anything talking about proper fractions, you know, it's just a fraction where the numerator is less than the denominator. All right, we're moving along. We have here now an improper fraction. So you're gonna also write this. You're gonna write improper fraction and you just write the example. So you have an improper fraction and you have your examples here. So improper fraction is where the numerator is greater than its denominator. Again, this should be a revision for most persons. For other persons who are learning this for the first time, that's perfectly okay. Please let me know because then I would give you some more in-depth notes from the textbook. I'll tell you what pages to go and read. So don't feel overwhelmed if you do feel overwhelmed. All right, so we have an improper fraction and it's the opposite of proper, obviously. So in this case, the denominator is bigger than the numerator. So you have 31/4, -15/2, 23/9. Then you have the next type of fraction, which is the mixed number. So you're also gonna make note of that, a mixed number, and you're gonna write the example of the mixed number. So you should know proper fraction, improper fraction, mixed number. Those 3 very, 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 very important skills. Very, very, very important. Okay, so we're keeping it moving. Now, let's go through this quickly. This is just to make sure we're clear on the different types. So you're gonna state which of the following fractions is mixed, improper, or improper. So for the mixed, you can just type M, so you don't have to type out the whole word. So for mixed, you can type M. For improper, you're gonna type I. For proper, you're gonna type P. Everybody ready? Let's go. A, what is A? Very good. Simple, straight to the point. B. Okay, so we got some different answers. Keeping in mind, what do we have here? We have here the numerator is bigger than the denominator. So here in this example, it has to be an improper fraction. Okay, keeping in mind the mixed fraction is when you have both what? A fraction and a whole number together. So that would be A, but B would be our improper fraction. Let's go C. Excellent job, guys. Excellent job. D. D. Excellent. Improper because 20 is bigger than 13. What about E? Excellent. F. Excellent. G. That's right. So we need to make sure we understand the difference between them. And now we're going to look at how do we go from one to the other. So this is a little bit confusing. So I'm going to do, it's not really confusing, but the way it is, let me go through it and then I'll give you my even more simpler version of it. So we're looking at converting improper fractions to mixed numbers. So that's your new topic head. So you are going to write this out in a bright color because again, the new topic, converting improper fractions to mixed numbers. This skill is probably the most important skill you are going to need for question number 1, because most of the fractions you have to add, that's the first thing you're going to do on the paper, and you want to be very comfortable and you want to be very confident. And in order to add the fractions that they will give you, you have to be able to do this very easily and very quickly. So let's look at it. So we're looking at changing from an improper to a mix, and the process is pretty easy. Remember when we were looking at the different meanings of this, when you got something over something, all it simply means is 7 divided by 3. 7 divided by 3. But luckily for you, you're only looking to see how much whole numbers you have, and then the remainder would be your new numerator. So let's look at it. How many times can I get 3 from 7? So here, they did the long division. So you realize they divide 7 by 3. How much did they get? They get 2. And then they had 1 remaining. So that means that I could get 2 wholes. And if I get 2 wholes, how much out of this would that be? That would be 6 pieces. But I have 7 pieces. So how much gonna left back? 1. So this one would become our new numerator. Everybody see that? So let's look at it. So you're gonna write down step 1. I need everybody to write this down right now because this is important. Step 1, set up the division problem and divide 7 by 3. Step 2, the result will become your whole number. And your remainder will become your new numerator. So I'm going to take this opportunity to just move this over to the side for us to work on some examples together. So I'm going to give you, let's do something pretty simple and straightforward first. Let's do 8 over 5. 8 over 5. While you write 8 over 5. How do I change this to a mixed number? So step 1, I have to divide the top number by the bottom number. I can ask myself, you can use the calculator, but remember we're trying to learn how to do with the calculator and without the calculator. So step 1, how much times can I get 5 out of 8? Only once. I can only get 5 out of 8 one time. And when I get it one time, I end up with 1 whole. So when I take out the 5, how much is left? 3. So your answer is 1 and 3 over 5. Okay? Let's do another one. Let's do 10 over 4. And you realize I did this without the long division because let's be real, I don't want to, this is the long way to do it, but I don't want y'all to spend all that time doing it this way because you need to be able to do it at a drop of a dime. That's where I want us to get to. This is just for your general understanding, but we need to practice being able to do it directly. So let's go. If we're looking at our tables, how many times can I get 4 from 10? How many groups of 4 can I get from 10? Talk to me in the chat. 2, because I know I could get 8, right? So if I get 2 groups, we write that as our what? As our whole number, right? So we're gonna have 2 as our whole number. And if we have 2 groups of 4, that means we have how much? 8. So if we took out 8 from 10, how much do we have left back? So I'm just gonna put here minus 8 to just show you how we get the remainder. So we end up with 2. So our answer is 2 over 4. Everybody see that? Now I'm gonna tell you something in general. We don't accept fractions like this. We accept fractions in its lowest terms, but that's not our focus right now. So we're gonna come back to that. Let's do another one. Let's do 12 over 5. Let's go. What would I get? How much wholes? 2 and 2 over 5. Everybody agree? Because you can get 2 wholes, and when you get 2 wholes, you end up minusing 10, right? And when you minus 10, you're gonna left back with 2 over 5. Excellent. Let's do one more for the road. Let's do 9 over 3. Let's do 9 over 3. What do we get? Excellent job, guys. We just get a whole number because we don't have no remainder. So we literally just gonna get 3, and that's it. So that was a trick question. Excellent job. One last one. 11 over 3. Let's go. Give me the whole answer. What would this be as a mixed fraction? Okay, so I got one answer. Excellent. I could get 3 groups of 3 from 11 because that's 9. And I'm going to put minus 9. So how much I have left back would give me 2. So my answer is 11 and 3 over 2. So everybody understand this? Talk to me before we move on. So everybody get this? Everybody feeling okay with this? All right, bless up yourselves. Excellent. So let's move to the other one. So we don't need to do this. This would be something you would do if you want more practice. You do that on your own and you get your reinforcement. So let's go. We just changed improper fraction to mixed number. Now we're going the opposite way. We're going to change mixed numbers to improper fractions. So just write down the topic head. Write down the topic head, and you could leave some space to write this down after, because this is important to write, but you're just not going to write it right now. So get that done for me, please. Write down a new topic head. Leave your space for this so that we could move on quickly. Again, there should be some revision for some persons, and for other persons, it would be new. It might be a really necessary revision. So if you have to go back over everything again, don't feel, do it as much as you need to. All right, so let's go. How do we change from a mixed fraction to an improper fraction? So we're not going to even look at that example. Let's look at it here. 2 over 3 over 7. And this is how I do it. I like to circle and do like it's like a cycle of operations. So the first thing I do, you have to do this. You have to take the denominator, multiply it, so you realize it's the opposite. Let me go back because I want to show y'all something, how math's so funny. And when you think about it like that, you would realize everything is so connected. What did we do to do this? What was the process? You realize our process was division and what? then subtraction, right? Everybody realize we had to divide first, and when we divide, we had to be subtract to find the remainder. Watch what's going on with this version now. We're gonna do the opposite. So instead of dividing, guess what we're gonna do? We're gonna multiply and add. So that's how math is. We're doing the opposite thing now. We do the opposite operation. So you would say 7 times 2, and then you're gonna say plus 3. So let's look at that. What would that be? 7 times 2 is 14. 14 plus 3 is 17. And then you put it back over the old denominator. So it's going to be 17 over 7. Everybody realize that? And if you think about things that way, you would realize you're going to remember easier. Oh my God, is this the opposite thing of turning it into a mixed number? You know, we're doing the opposite things. We just do the opposite operation. So let's do another one. Y'all ready? Let's go. So change this one for me. 2 and 3 over 4. Everybody, talk to me. What is this? Because if we could lock this down quicker, we could move faster. What would this be as an improper fraction? Okay, I get 2 answers. 3, 4, excellent job. So do the same thing again. Follow the cycle. 4 times, and we add. So it's going to be 4 times 2 is 8, and 8 plus 3 over 4. So our answer is 11 over 4. Let's do one more. Let's do one more. Let me give you something. All right, work that one for me. I hope you all wrote these examples in your books. Excellent. One person sent the answer. Everybody else? Excellent job, guys. Excellent job. So before we move on, how y'all feel about this? Because this is very important. This is actually very important. So talk to me. Y'all feel comfortable with this one? All right. Okay, good. All right. So we're moving along. Again, we have reinforced questions, and I hope you all really take the time. Remember, in the orientation, I would have told you that you should have another day where you're designated as a match day to do some practice, to do the assignments and all of that good stuff. So don't be afraid to go back through the presentation. I showed you guys where it is. Don't be afraid to go back through it and strengthen your skills, okay? Now this is where we're gonna look at, let me just see something here quick. Okay, I just wanna make sure the last 2 things we're gonna do today. And that's it, okay, that's it, yeah. So we can start there. So equivalent fractions. Now this is also very important because this is gonna come in handy for ratios. This is going to come in handy for a lot of things. So just write the topic head. Don't write none of these other things. Just write the topic, equivalent fractions, and we're gonna move forward. Okay, and keep it in mind, for each individual person, some things may be more challenging to others. Some things that might be easy for you might be challenging for others. Some things that are challenging for you might be easy to others. So it's very important for you to pay attention to the things that you may have some difficulty with and write it down. So after each class, if there was something that you didn't get strongly, I need everybody to always write down things to revise or things to back check or things to strengthen, because that way you focus on your weaknesses and make them strengths. Everybody with me? And then you could always message me as well to get any additional assistance. All right, equivalence. When you hear the word equivalent, the first thing that should come to your mind is equal, okay? Equal fractions, so fractions that are looking different, but they are equal in quantity. So these are some examples. This is how you should visualize it. So we have here the first diagram. We got 1/3. So something is cut evenly. That's very important because remember with fractions, each section must be of equal size. So we have 1/3 shaded. That's why we have 1/3. The second one, we have how much pieces? 1, 2, 3, 4, 5, 6, and we shaded 2. But when you look at it, even though it's two different fractions, it's really the same quantity. So that is what we consider equivalent fractions. So fractions that look different, but they represent the same quantity. So that's the first concept you need to understand. So if you look at the bottom, we realize we have a whole and we have a half. But a half is the same thing as having 2/4, if you realize. A half is the same thing as having 4/8. That is what we look at when we think about equivalent fractions. So what we're gonna do easily here, I'm gonna do a quick activity for us to be able to find our equivalent fraction. So let's look here. So I'm gonna have I'm gonna have 2/3 is equal to something over 6. In maths, you use what they give you to find what you need to know. We need to find what the numerator is, but let's look at some things. Here, it moved from 3 to 6. How do you move from 3 to 6? By, you put your arrow. What did you do to get from 3 to 6? You multiply by 2. Whatever you do to the top, whatever you do to the bottom, you must do to the top. Because what do we do in math? We always maintain balance. So what would be my equivalent fraction then? My equivalent fraction would be 4/6. Everybody sit down? I'm going to give you another example. B. What would be my missing number? How would I find my missing number? Here, again, we look at what they gave us. They gave us 2 denominators, but we're missing a numerator. So we need to figure out, how do I move from 5 to 20? Somebody said multiply by 4. Excellent. And now I'm going to tell you guys something. If you don't know your tables, you're going to really struggle unnecessarily, because there are certain things that you should be able to look at without your calculator and know. All right, 5 times 4 is 20. That means 4 times 4 is 16. Okay? So if you're not there at this moment, put the work in and learn your tables. So let me go. So here, to move from here to here, please copy down these examples now. So under the topic, this is what you should be writing. So you multiply by 4, and you see the use of the different colors. Please use a different color pen to do so as well, so that you could see what you are doing. Times 4 is 16. Now I'm going to give you a more challenging question, because you know that's what we just do wrong here. So I'm going to give you, let me see, 4/8 is equal to 2/. Who could figure out this one now? Challenge. Let's see who's thinking. Look at it. What did they give us? They gave us 4 and 2. But what's going on here? Are we multiplying in this example, or are we going to do something else? Because we're moving from a big number to a small number. That's how you are supposed to be thinking. Exactly. So you divide, because obviously you have to move from 4 to 2. So what do I do to go from 4 to 2? I divide by what number? 2. So I see some people sharing the answers. Very good. So from here to here, I divide by 2. Whatever you do to the top, you must do to the bottom. So you divide by 2. And so what would my answer be? 2 over 4. Excellent. And guess what I'm going to do now? Guess what I'm going to do now? Who could tell me this one now? What would the answer be for the next one? How do we move to the back? How do we get our last one? What would the answer for the box be for the last one? Anybody? Excellent. 1. Excellent. 1 over 2. So we move from here to here. We divide by 2 again. Whatever you do to the bottom, you do to the top. So you divide by 2. So your answer is 1. That's how you find equivalent fraction, guys. And the trick is, every question is not going to be the same. And that's one of the things you need to mentally prepare yourself for. You never just jump assuming that you know what to do. You watch, you see what they give you, and you make a decision. In this case, we were increasing. So obviously, okay, I have to multiply. But in the last example, why did we have to divide? Because are we increasing? No, we're not. So we can't multiply. So if we're decreasing, that means what other operation would be equivalent to decreasing but opposite to multiplying? Dividing. Okay? Ash, you see that? Okay, excellent. So that's how your mind should be thinking. You look and you watch. Oh, this example is different because we're not increasing. So if we're not going to increase, that means we're not supposed to multiply. But what is the opposite of multiplying? Oh, dividing. And you try division and see if it works. And boom, it works. Everybody got now? Talk to me. Talk to me, talk to me, talk to me. Talk to me, talk to me, talk to me. So that's how you get equivalent fractions, okay? This is going to be important for adding and subtracting fractions, because when we get there, you would realize why it's important. Ashley, even if it's not very strong, just take note of it. We're gonna do one more. And then we're gonna move on. Okay, and you could always look over it again. So let's try one more for the root. Here we go. All right, so let's look at this one. In this example, guys, what are we doing? Are we multiplying or are we dividing? Excellent. So I see divide, we get a half. Good. So we need to identify what is our number that we need to divide by. How can I move from 10 to 2? I can divide 10 by 5 to get 2. So that means whatever I do to the top, whatever I do to the bottom, I do to the top. So I divide by 5 to maintain the balance. And so 5 divided by 5 is 1. So that's how we get our answer. Pretty straightforward. All you have to do is pay attention to the details. All right, so we're gonna move forward because we really need to finish this fraction segment, because in order for us to do what I need us to do next week, which is to start our paper 2 type questions, we need to finish this foundational stuff. So let's look at this. This is also important. Anytime you get a fraction, you have to simplify to its lowest term. To simplify any fraction, you have to divide. So what you're gonna write for me is to simplify, you divide. To simply, if I spell something wrong, guys, don't be too alarmed. Sometimes I struggle with spelling. simplify. So you put to simplify, you're dividing, you're using division. You're dividing by the common factor. By common factor. Common factor. And let's look at some examples. So all these skills are skills we're going to need to use for paper 2 and paper 1 too. All right, so let's go for the first one. So step 1, identify the common factor. What does that mean? You're looking for a number that you could use to divide both the numerator and the denominator. Anybody have any ideas? What number can we use to divide both the numerator and the denominator? What's common between 3 and 9? And this is why your multiples is important. 3. So for now, I am literally going to do the long way just for us to make sure we understand. So we divide by 3 to the top. We divide by 3 to the bottom. Remember, you have to maintain balance. Whatever you do to the top, you do to the bottom. So what we're going to end up with is 1 over 3. So that's your first answer. So let's look at B. Same thing. What do I do? What is common between 3 and 12? 3. So we divide by 3 to the top. We divide by 3 to the bottom. This is what we call simplifying. Is the operation of dividing by a common number, a common factor. So let's go. C. So write down these 3, A, B, C, D. Let's do them together. So we're going to do right now, what we're going to focus on is A, B, C, D, E. Because I'm going to show you guys how to deal with the bigger questions. Because sometimes you would have to divide more than once. So for example, if you're in a situation where you don't remember the highest common factor, you could use 2. So I'm going to use this example to show you guys what I mean. So get your answer for C, please. Get your answer for C, and I want to demonstrate. So let's say you see 8 over 20, you can't remember what number could go into both of them. But you remember that both of them are even numbers. That means they could be divided by 2. So let's say you work with what you know. You use 2. You divide by 2. So you break it down. What you're going to end up with? 4 over 10. What are you going to realize? Oh, I can divide again because this is not my lowest term. I could break this down again by dividing by 2. So you go again. Remember, math is not just one way. You have to find a way that is the easiest for you or the simplest for you. So yes, 4 is correct. No, 4 is correct. I'm doing it this way for persons who may not realize, okay, 4 is the common denominator. So 2 over 5. So this is the long way. In case, for example, you're in a moment and let's say a blank out and you can't remember. Simple, keep it simple. For those persons who are aware of the highest common factor 4 and 20 is 4. That means 4 is the biggest number that you could divide 8 and 20 by. So you divide by 4 to the top, you divide by 4 to the bottom. So your answer is 2 over 5. All right, what about D? What's the answer for D? So we're doing D and E. Where's my remote? Somebody said 5 by 5 over 7. Anybody else have the answer for D? Okay, waiting for everybody else. Remember, all this is practice, okay, guys? So everybody else do D and E, and then you could always finish the others. I recommend everybody writing on all because this skill is a very important skill. Very, very important. Okay, good work, guys. That's correct. 5 over 7. Anybody have an answer for E? Excellent, 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 excellent. So that means let's do a quick recap before we move on of what we've done with fractions, because I want you to make sure you store the information in your mind. Make sure you organize it and understand the difference between everything we've done so far as it pertains to fractions. So what we looked at first are the different types of fractions. We have proper fraction, improper fraction, mixed fraction. We learned the difference because we make sure we're able to identify the difference between all three by just looking at it and knowing the properties of each. Then we were able to convert from improper to mixed by doing what? Dividing and subtracting. Then we did changing from mixed to improper, which was the opposite. So we multiply and we add. Then we looked at equivalent fractions. So how can I find a fraction that's equivalent? If they give me two fractions and they ask me to find a missing value, I can set it out in such a way where I can calculate the missing value for equivalent fractions, okay? And this is going to be very important later on. And just keep this in mind that I showed you guys this format when it comes to finding missing numbers, all right? Then we looked at simplifying. So anytime you work out any fraction, always break it down to its lowest terms, guys. You will not get full marks if you do not. So this is very important. And we use division by a common factor to simplify. So anytime they say, calculate this to the simplest form, you should know. When you calculate your answer, you break it down to its lowest form by dividing by a common number. All right? Now we go into the meat. We are going to the meat of our class today. But it's 8:20. So if anybody, y'all tell me what y'all want to do. Because again, remember, I'm on vacation right now, so I could give you some extra time. So if you want us to push as much as we can now before school open, that would be recommended. But let me know what y'all want to do. Y'all want to go forward with addition and subtraction at least today, and then or you want to stop here? So tell me what y'all want to do. Because I know we did a lot. We did a lot. So tell me what y'all want to do. Y'all want to stop here, or y'all just want to finish it so that we could continue next class with our paper 2 stuff. So I'll just wait to hear what y'all think. Don't be afraid to say stop, you know. Okay, so we're gonna stop here. All right, you see, that's all it takes, you know. It's all about communication, okay? It's all about communication. So I wanna take this opportunity to show you guys something. So I'm gonna end the recording here. Should I leave it? Let me see, because I wanna show y'all something. Okay, awesome. So we can stop here. So I just want to outline something quickly before we leave, just so that we could keep an idea. So to be honest, we are not really behind, but we are a little bit behind. I made some adjustments to the schedule so that it could be more effective. Let me see. So I'm going to show you guys where we are. So from our first class, we covered 1, 2, 3. But here's the joke about that. So far, we did out of operations, right? We did addition, multiplication, subtraction, and division of whole numbers. Right now, we are on fractions. We finished decimals, so that's a good thing. So right now, once we finish fractions, and we need to do converting, all of this could be done in one class, to be honest, so maybe next week. And so, yeah, we are a little bit behind, but I feel like we could catch up. this is what I wanted to show you guys, but the pad cut off. I'm gonna make some changes. I'm not giving y'all a test again. So this test thing here gonna come out. We're not gonna do a test anymore. So I'm gonna use this as an extra class. So I'm gonna push the past papers down, a recap class. And so we're gonna have one extra class to give us some chances to pick up on anything we fall behind on. So use this guide, guys, in your own time. And I think, yeah, that's about it for today's class. So now I just need you guys to give me some feedback. How was today's class? Are you left more confused? Did you learn anything? Was it effective? Was it beneficial? Give me out of 1 to 10, how much did you learn? How you feel about what you learned? 5 being that you feel halfway comfortable, 10 being you feel extremely confident, 1 being you don't understand anything that we did. So talk to me so I could see. Okay, 7, 7, 9. It was good, understand fractions and divisions better, okay. 9 out of 10, okay. And remember, it's not just me you're rating your understanding, okay? Because that's the most important part for me, to make sure that everybody leaves with he's a scale break. Good. All right, guys, so that's it for today's class. Thank you all for being here. The last thing I have to tell y'all is that although this session is for free, everybody might not move forward to my actual classes, because the truth is, I like to work with people who are consistent, with people who communicate. So far, everybody's doing pretty well to move forward with me, but just making sure I tell you guys from now that I will be making a decision on who I move forward with, because I really don't like investing more than people invest in their own education. So once everybody keep up this type of interaction and participation and showing up for classes, because I take register, we should be good to go. All right, you can message me with any messages. See you guys next week, Monday. Zoom link will be posted in Google Classroom. Have a good night.